Good morning, everybody. Today we're going to be doing super exciting stuff. We're going to be graphing, my favorite thing ever, and I'm sure it's yours too. So, if you are someone that hasn't been printing these out or following along, this is going to be an especially important one for you just to try out. So, even if it takes you longer to go through this lesson, try it by hand so you can count that towards your 30 minutes. Just wanted to preface that because it is just practicing graphing. So if anything, I want you to do that. But without further ado, let's get into it. So graphing sine, think about the unit circle when you're doing this. Let's go page width. Unit circle, we're going to be, so thinking about that, we're starting at 0 with sine, and I'm starting to increase as I'm going up to the unit circle. It peaks, or it gets to the highest point at pi over 2. So that is an important number to graph. And then it starts to go back down and until it gets to, or it crosses 0 at pi, and then it keeps going down until it gets to the lowest point at 3 pi over 2, and then it starts to go back up, and it just keeps the same cycle over and over and over. So we have a couple of things to talk about. One is called the amplitude. Amplitude is basically the furthest, the distance between the peak and the midline, or the middle of it, basically halfway between the peak and the lowest point. And then there's also the period, which is how long it takes to go through a full cycle of coordinates before it starts to repeat itself again. The period, unless we change things for sine and cosine, are 2 pi. There's only one question in here where we're messing with the period at all. So for just graphing sine, it starts at 0 when I plug in an angle of 0. X-axis is going to be our angles. The y-axis is that sine value. So it's not going to be a unit circle that we're graphing, but it's based off of that. And then I like to space it out a little bit. The next important point I said earlier is pi over 2. At pi over 2, I'm going to scale this a little bit. So this is 1, -1, just to spread it out. So this is 1/2. Pi over 2, we're at 1. And then at pi, it hits the x-axis again. At pi, the sine value is 0. 3 pi over 2 is the next big one, or at least the next easy one to graph. You could graph, so that should be 3 pi over 2. You could graph pi over 6, you could graph pi over 4, you could graph pi over 3, but those aren't the nicest numbers to work with, especially if you're using this scale. Pi over 6 is 1/2 for sine, so that would be the one that I'd want to graph, but it doesn't really fit well in terms of how I scaled it here. So you could do more points if you wanted to, but you're going to be estimating the curve anyways, so you don't have to do it that way. 2 pi is the next big one, and if you notice, this would be one full cycle. After this, I'm just repeating values, and you might notice a pattern, at least with those points that we're going across. You could do this little jagged line thing that's going on. I'm going to quit adding stuff to my x-axis just because it gets a little messy. But over 2, either up 1 or down 1. So over 2, and then it goes back up. This would be another full cycle. I'm just going to fill the page. You want at least 2 cycles of your function. That way you can just see the pattern a little bit better. But finishing it off with arrows. Go in both directions. You can plug in negative values, so your graph should have that. As far as the rest of it, you're just kind of estimating the curve here. Do not draw a jagged line. It should be curved. And finish it off with an arrow to show that it still is continuing. So that is the sine function. Nothing much else to it. Scale is super important on these. Make sure you're scaling it correctly. And oftentimes, you will see in a second on the back side of this, or with cosine, that most of the time I'm just kind of playing with the scale instead of actually moving things or making it look different. And the biggest reason for that is that I scaled this to begin with. Most of the time you're going to run out of room if you don't scale. But keep that one in mind for the rest of these. Sine of x minus pi over 4. So if you remember from pre-calc A, if I am subtracting inside of parentheses, I'm moving left or right. In this case, I'm subtracting, so I'm moving right pi over 4. And I am going to cheat a little. I don't think those are the same size. Okay, so the normal function, keeping the same exact scale would look like this. So if I kind of scale, that's why. Okay. No, I'm good. Sorry. Careful, these can get away from you. Like mine was starting to right there. If you are shifting to the right pi over 4, pi over 4 for me is 1 unit along the x-axis, so I just have to move everything 1 unit to the right. So if you are like me and you can just move everything like that, you're good to go. If you aren't, then you would have to just rewrite this. But that would be sine of x minus pi over 4. It's the same exact function, just shifted to the right pi over 4 units. So picking a good scale helps with these. Negative sine of x is going to flip the function, so it's going to start by going down from 0, 0, except it gets shifted up 2 as well. I'm going to go ahead and flipping it is easy enough to graph, so I'm going to start by that. Same scale, pi over 4 for my x units, and then 1/2 per y unit. Ideally, you would label that every single time, but I don't want to make it super messy. Okay. Pretty good. So now shifting, notice that the +2 is not inside parentheses versus this where it is inside parentheses. This is taking all the values and adding 2 to it, not the angles. This is taking the y values and adding 2. So you're going to take your function and you're going to shift up 2. So it would have been nice if I would have done a different scale here. Right now my peaks are at 4. My lowest points are at the x-axis, or they should be. You kind of got a little squirrely over here where they're not on there. But 4 is where these should be. It would have been nice if I just did a 1-to-1 for my y values. That way it would be on 3 here, or it would have just fit better in there. Yeah, okay, so there's that. Okay, good. It would have been on 2, sorry. Whoa, woo. So it would have been, these peaks are at 2, not 3, or whatever I said. I think I said 4, whatever. But what am I doing? Beautiful lesson, everybody. Hope you're paying attention to this. Beautiful, beautiful. Okay, Okay, so the peaks were at 1. If I add 2 to that, that's 3, everybody. That's keeping track at home. So the peaks should be at 3. Right now they look a little off, but again, this is hand-drawn. Peak should be at 3. All right, struggle bus on my end of this. Hopefully that's not too confusing. All right, cosine. Cosine, if we're, again, thinking about the unit circle, cosine starts, cosine, oh my, deep breaths everyone, we'll get through this. Cosine on the unit circle starts at 1, and then as I'm adding to the angles, it starts to decrease, still decreasing. It's 0 at pi over 2. Again, when I'm thinking about cosine, so cosine of pi over 2 is 0. Cosine of pi is negative pi. And then cosine of 3 pi over 2 is 0. So it starts to increase, and it keeps increasing until it gets back to the starting position at 2 pi. So key points here is it starts at 1, and then at pi over 2, the x value is 0 of the unit circle. The y value of cosine, or cosine, is 0 at pi over 2. Then the next important point is pi, and cosine of pi is negative 1. Cosine of 3 pi over 2, which should be not there. Cosine, so 2 lines over, we have 3 pi over 2, which should be at 0, 0. And then at 2 pi, we get back to 1. So one full cycle looks like this versus sine, which starts at 0, 0 and starts by going up. But this just gets copied all the way through. So you could duplicate that and then join them together. Should match up if you are an accurate grapher. And like so. Duplicate. And voila. So it should just work that way. Obviously, you should be able to just keep copying points, but if you have a full cycle, you just know that it's going to repeat itself over and over and over through that. You might notice that it looks a lot like a sine function. Cosine and sine are very much related to each other. They just have different starting positions. So keep that in mind as you're going through those. These get a little bit more challenging because cosine, I'm messing with the height and the period of cosine. So scale is going to be super important in these. I'm going to change the scale to a 1-to-1 on my y values here, but it makes it look like the same thing because I'm now squishing everything vertically so I can stretch it vertically. Basically, the picture is going to look the same, but if you're keeping note to the scale, it should be different. So again, it would start at 0, 1, but I'm multiplying cosine by 2, so 0, 1 times 2 would be 2. And then same thing with down here. At pi, cosine of pi is negative 1, but 2 times that would be negative 2. So it gets scaled vertically. And again, it should if you do this right, if you're playing with the scale the correct way, it should just look like the last function we drew, which is kind of nice. I would rather change the scale than change my method of graphing, so pretty helpful when you're trying to scale or when you're trying to graph things that have been scaled. All right, here's where things get a little weird. Again, the hardest change is the horizontal changes. And if you remembered pre-calc A, again, inside of parentheses changes horizontally, and it does the opposite of what you'd imagine, or what I would imagine at least. If I'm multiplying, it feels like I'd be stretching. And if you're multiplying inside parentheses, you are compressing. So think about this number as how many full cycles you can fit in the normal cycle. I should be able to fit 3 full cycles in between 0 and 2 pi. That's what this is saying. So the number of things I can fit. Because it's accelerating the cycle. So I should be able to fit 3 times as much information into the normal one cycle. So just be careful. Really, this just changes your scale again. So I'm going to divide all of my values by 3. I have been saying pi over 2, so pi over 2 divided by 3 is pi over 6. So really, I have a pi over 12 scale going on. Starts here, goes down. The next thing would be 2 pi over 6. You can leave it as 2 pi over 6, or you can simplify it to pi over 3. I don't know which one's easier for you. And then 3 pi over 6 is pi over 2. I'm going to try to give some space, so pi over 2. And then 4 pi over 6 is 2 pi over 3. And that should be our first cycle. Okay. And then it goes back down. So again, 2 pi over 3. Normally a full cycle fits into 2 pi, but we should be able to fit 3 of these in between that and 2 pi. But basically, again, the easy thing is to change the scale rather than change the graph. So your graph should look like this. And that's all there is to it. So practice those graph transformations, but really changing the scale of your graph is the easiest way to do this. And that is all I have for you today. And this is a two-day portion, but check in tomorrow for the next lesson, and I'll see you then.